Welcome everyone. So today I'm going to teach you logarithms, okay, or we even call them as logs. Now this topic has a weightage of what 1 to 2 questions in CAT. Now you might be wondering that it has just 1 or 2 questions, then why should we bother, giving attention to this one? The reason for that is because these are straightforward questions and they can be literally done under 1 minute. Okay, so yes, this is one of those topics. If you can understand it properly, like I'm going to teach you today, once you understand the basics, there is literally very rare or very little scope for you to go wrong in this one. Okay, so now, like for any topic, there are few basic things you need to know. Here the most important things is the rules of logs. If this is like completely sorted in your head, then there is a very rare chance that you won't be able to get these questions. Okay, another thing which a lot of people miss out on is indices. You need to have a clear understanding of indices as well. Okay, so don't worry, we are going to focus on both of these cases. Okay, so let's try and understand the rules first. The first and most basic rule of log is log of a to the base a is always 1. Log of 1 to any base is always 0. Log of 0 to any base is always undefined. This is basic. This is something which you need to always remember. Next, see, if you see in college or whenever we had math and we were solving logs, we always had something with log of a. And if there was no base given, that base was understood as 10. Okay. But here you will see that lot of times you will be given a base. Okay. And if that is the case, you can convert it into a fraction by writing it as what? Log of a to the base 10 and log of b to the base 10. Okay, which can effectively be written as 1 upon log of b to the base a. Okay, so yeah, another thing is that if you had log of a to the base b, if it is given given equal to some value, so from here you can completely discard the log and make it equal to a equals to b raised to m. Okay, so I hope these few things are completely clear to you. Okay, now let's come to another basic, which is log of a raised to m. Yes, I know a lot of people know this. This is m log a. But at the same time, if I had also a base with an index, then in that case the index becomes the denominator of the whole log. Okay, next, log of a product. This is quite important because people mess up here. Log of a product can be broken, or rather can be written as log of a plus log of b. Okay, so please understand that log of a multiplied by b, this cannot be equal to log of a multiplied by log of b. No, that's not okay. Understood? Now next, log of a upon b is equal to log of a minus log of b. And last but not the least, it is a raised to log of b to the base a. If you have something in this format, then this entire thing becomes 1. So basically this becomes 1 multiplied by b. So the answer for this one becomes just b. Okay, so today we are actually focusing more on solving or using these tricks to get your answers. Okay, so if you want me to delve into certain y's, like y is log of 0 undefined, or y log of 1 is always 0, or why this is working out this way, or why this is working out this way, then please let me know. So I will prepare a separate video on the same. Okay, now coming to indices. Okay, before going ahead, I want you all to take a picture of this, or take a pause on the video and start writing these laws. See, I personally as a quant tutor would want you to write it down. I know in today's digital age a lot of people think that writing is literally so outdated, but trust me, if you want to crack any of the entrances, writing is your weapon. If you can write it down, means it is going once what happened was, you were listening to me and you were looking at it. Okay, the second time when you write it down, it happens like it gets registered twice in your head. Okay, so I would want you to take a pause at this video and first finish down making notes of this one. Okay, then let's move on to the next slide. Now, like I said, we'll talk about indices as well. I know a lot of people will feel that indices is something which is so basic. If you think your indices is quite strong, you can move ahead. Okay, but if you think indices is something which you need to brush up on, then please pay attention. See, a raised to m multiplied by a raised to n can be written as what? A raised to m plus n. Similarly, a raised to m upon a raised to n can be written as a raised to m minus n. In indices, a raised to m the whole raised to n can also be written as a raised to n the whole raised to m, because this eventually comes down to a raised to m into n, or a raised to n into m. Okay, and as we know, multiplication in mathematics is a commutative law, means a multiplied by b is equal to b multiplied by a. Okay, this is what a commutative property states. Okay, yeah, and if you have something of this format, a raised to n plus a raised to n plus a raised to n, okay, so in that case you cannot add the indices, you can just take a raised to n common, and whatever is left, like let's say it was 2n over here, so 1 plus 2 plus 1, so eventually this comes out to be 4a raised to n. So I hope you are understanding how to solve, or rather how to use indices. Okay, now a raised to any number, a raised to 0 is always 1, and if I write just a, means it is equal to a raised to 1. Okay, another thing, that if you had 1 upon a raised to n, if you want to take it back on your numerator, it is written as what? A raised to minus n. So I hope you are understanding. In case I have missed out on any of these laws, I will come back to this slide and add few more. Okay, but like I said, the same thing for indices as well. I would want you all to take a pause at this video and please make a note of this. Also, going forward, how our classes will be structured, or how I want you to make notes is, whenever we start a topic, okay, I want you to keep one page completely blank before starting with sums. Why? Because in that one page you will type, or you will write tips or tricks or notes about certain sums where you thought that this method was so much easier that you could solve this in seconds. Okay, or you used some other technique which you are sure that today you are remembering, but maybe while revising you might forget. So that one page means 2 sides is your notes. Okay, that is something which you will refer towards the end while preparing or while revising the concept. That is something which you will revise. Okay, and in that, when you are making notes, I want you to write down the sum number as well, so while revising you know which sum to refer to for that particular trick. Okay, so I hope this is very clear to everyone. Now let's start with few sums. So let's see over here I have few basic sums, which is 81, raised to 1 upon log 3, wait, let me write this again, log 3 to the base 5. Okay, so when you have something like this, at this time, what we should do? This is one question. Another question which I think we should solve, or we can solve, is log of log of 81 to the base root 3. Okay, so these are the two questions. I want you all to take a pause and try solving them on your own. Okay, see what happens is, when you look at a question, it looks tricky. So if you think that this is so difficult, then what we should do is, we should use the, yes, right, we should use all the laws of logarithm which I had explained. Okay, now over here what we should use, okay, like I had said, there was a rule of logarithm which says 1 log of a to the base b can be written as 1 upon log of b to the base a. And why like that? Because if I shift this 3 over here, maybe my problem might be solved. Why? Because see, a raised to log of b to the base a is nothing but just b. And we all know that I can write 81 as nothing but 3 raised to 4. And here I can write it as what? Instead of reciprocal, I can write it as log of 5 to the base 3. Okay. Now after this, please understand, here if I want to use this property, I need to realize that here there was nothing given. So I need to get rid of this 4. How do I get rid of this 4? As we know that log of a raised to m can be written as what? M log a. Correct? So this becomes 3 raised to log of 5 raised to 4 to the base 3. So now this has come down to this property, and this eventually comes down to 5 raised to 4, which is equal to 625. This, my dear friends, is the answer for this particular question. Now similarly for this one, what we should do? See, for this one, please remember, I'll give you a hint. We should go from outside to inside. So here we can write log of to the base 3, okay, log of to the base 2, log of 81 can be written as what? 3 raised to 4, and root 3 can be written as what? 3 raised to half. Okay, now at this point, realize that I had also given you one rule which says log of a raised to m to the base b raised to n can be written as m upon n log of a to the base b. So using this, I can write this as what? Log to the base 3 log to the base 2, and I will write it as what? 4 upon 1 by 2, which eventually comes down to log to the base 3 log to the base 2, and this becomes 8. And 8 we know it becomes nothing but what? Log to the base 3 log 2 raised to 3 to the base 2, which can be written, now the index can come ahead, so this can be written as log 3 to the base 3 into log 2 to the base 2. And we all know log of any number to the base of the same number, the answer is what? 1. 1 multiplied by 1. The answer for this question comes out to be 1. I hope this is very, very clear to everyone. Okay, so now let's understand if I had given you something else. Okay, so here we are not going to use too much of logs. You are going to use log, but not so much. Okay, so if I had given you p raised to 3 equals to q raised to 4 equals to r raised to 5 equals to s raised to I'm so sorry, raised to 6, then what is the value of log of p q r to the base s? Okay, now in this case how you will do? See, your hint over here is that the base, see the base is s, so let's write all of them in base of or in terms of s, which means p cube equals to s raised to 6. Therefore, p equals to s square. Similarly, q raised to 4 equals to s raised to 6. Therefore, q, when taking the fourth root on both sides, I can say q equals to s raised to 6 by 4, which is nothing but s raised to 3 by 2. Similarly, r raised to 5 equals to s raised to 6. Therefore, I can say r, taking the fifth root on both sides, I will say s raised to 6 by 5. Okay. So now let's understand what is PQR. P multiplied by Q multiplied by R. Everything in terms of S. We have S raised to 2 multiplied by S raised to 3 upon 2. S raised to 6 upon 5. Now as we know, since the bases are same, we can quickly add the indices. So sorry, we can't do this directly. So 2 plus 3 by 2 plus 6 by 5. Okay, when I do this, it comes out to be s raised to 41. No, I don't think it is 41. It is 47. Yes, it is 47 by 10. So when I do this, I can directly put it over here. So instead of log of PQR, I will write it as what? S raised to 47 by 10 to the base s. So we can write it as what? 47 upon 10 multiplied by log of s to the base s. So answer comes out to be 47 by 10, because this value comes out to be just 1. Okay. So I hope you are understanding how easily you can do all of these kind of questions. Okay. Now let's try and solve few more, and after that we will do few PYQs as well. Okay. So here we have a question which says log of 3 to the base a equals to 2, and we have log of 8 to the base b equals to 3, and we need to find what is the value of log of b to the base a. Okay, so here first try and understand what will be the value of a. So we can say 3 equals to a square using the rule of log of a to the base b. If it was equal to m, I want to get rid of the log, I will say a equals to b raised to m. Correct? So therefore I can say value of a can be just root 3. And please understand, base or the actual argument over here, both of these values have to be positive in log. You cannot have a negative base. So value of a cannot be minus root 3. It will always be positive root 3. Similarly, here also I will say 8 equals to b cube. We all know 2 cube equals to 8. So I will write, instead of 8, I will write it as 2 cube, and we have it equal to b cube. Taking cube roots on both sides, therefore I can say value of b is just 2. Let's put it in this one, the value which they are asking us to find, which is log of, instead of b I will write it as 2, and instead of a I will write it as what? Root 3. Now this can be written as what? Log of 2 to the base 3, and we will take the index of root, that is 1 by 2, as the denominator of the log. So then this becomes what? 2 log 2 to the base 3, which then we know that m log a can be written as log of a raised to m. So this can be written as log of 4 to the base 3. I hope this is very clear to everyone. Now let's understand one of the PYQs. Okay. So here the question given was, it was not like very difficult, but it was something which a lot of people could not like get the hang of. We have log of x to the base 10. Sorry, no, this question was not asked as a PYQ, but something similar was asked in one of the papers. Log of root x to the base 10 equals to 2 log of 10 to the base x, and we need to find the value of x. See, one thing is like you can put the options. Okay, another thing, I am not solving questions with options. The reason for that is log is one topic where it is a very high chance that the question comes as a type in answer. Okay, then in that case you will have no option, but you will have to stick to regular methods. Okay, so now as we know that log of a minus log of b can be written as log of a upon b. So this can be written as log of x upon root x to the base 10. Sorry, let me write this one more time. Log of x upon root x to the base 10 is equal to log of 100. This 2 will go as the numerator to the base x. Okay, so this becomes log of root x to the base 10, which is equal to, okay, let's not do it this way, let's stick to the original thing, 2 log 10 to the base x. Now why did I do it that way? Because here also I have a log 10. So let's remember that we had log of a to the base b can be written as log of a upon log of b. Okay, so what happens in this case is, instead of root x, I will take the index out. So I will have 1 upon 2 log of x upon log of 10 equals to 2 log of 10 upon log of x. Cross multiplying, I'll take the 2 on this side, so this 2 and 2 gets multiplied. Okay, so here I have log x the whole square equals to 4 log 10 the whole square. Okay, now log 10 we know the value for that because there is no base, so understandingly the base is 10. So 10 log of any number to the base of same number is basically just 1. So 4 multiplied by 1, and this comes out to be 2 log x. So eventually dividing both sides by 2, I will say log x equals to 2, and in order to get the value of x, we know that the base over here is 10 and we want to shift it on the other side, or we want to remove the log to find the value of x. So it becomes x equals to 10 raised to 2, which is nothing but 100. So I hope you are understanding how to solve these kind of questions. Okay, so see, please understand, when you are solving these questions, you need to have a very clear understanding of exactly how to get about it. Okay, and that can only happen with lot of practice, and that practice will only happen if your rules of logs are completely clear in your head. Okay, you don't mess up on any of the rules. Once you are sorted with the rules, there is hardly any question which you can't solve. Okay, now let's solve one of the PYQs. We had log of x to the base 3 plus log of 3 to the base x equals to 17 upon 4. Now this looks only very tricky, okay, but please understand when you have to solve these kind of sums, let's start with very basic. We know this can be written as log of x upon log of 3 equals to log, sorry, not equals to, it is plus log of 3 upon log of x equals to 17 upon 4. Now let's write, or rather instead of doing this, let me do this one more time, because maybe we will be able to save one more step over here. Log of x to the base 3, and this I can write it as 1 upon log of x to the base 3 equals to 17 upon 4, sorry. So now let's try and write log of x to the base 3 as nothing but what, y. So I will write it as what, y plus 1 upon y equals to 17 upon 4. This comes out to be a quadratic, which comes out to be y square plus 1 is equal to 17y upon 4. So which then comes out to be 4y square minus 17y plus 4 equals to 0. Okay, so value, when you factorize this, it can be written as what, 4y square minus 16y minus y plus 4 equals to 0. See, here directly you can write it as what, 4y common, 4y minus 4y minus 4 minus 1 common, y minus 4. Sorry, here also we don't need a 4. Okay, so next what you can get is y equals to 4, or I will say y equals to 1 by 4. So here we all know that what is the value of y? It is what, log of x to the base 3. So log of x to the base 3 equals to 4. Therefore value of x equals to 3 raised to 4, and here also I have log of x to the base 3 equals to 1 by 4. So I can say value of x equals to value of x equals to 3 raised to 1 by 4. So either the value of x is this or value of x is this. Okay, so I hope you are understanding how to solve these kind of questions. Trust me, this was a PYQ. Okay, and if you actually had to do this, like if something like this comes, then if after this step, things are very very easy. This comes out to be quadratic, and by now your quadratic ideas should be like completely done, and you could have jumped from this to this step. Okay, I'm just solving this because I don't know exactly how well you know your quadratics. Okay, and if you want me to solve those as well, or if you want me to explain quadratics also in detail, please let me know, so I will do that as well. Okay, now let's move on to the next question. Okay, so the next question is also quite interesting. We have log of 27 to the base 12 equals to a. The next question we have is log of 16 to the base 9 equals to b. And we need to find the value of log of 108 to the base 8. Okay, so this looks quite interesting, and I'll tell you the options for this one were in terms of, one or two options were in terms of A and B, and then other two options, one of them was completely in terms of A, another was completely in terms of B. Okay, so now let's try and understand how do we do this. See, for log of 108 to the base 8 can be written as what, log of 12 multiplied by 9 to the base 8, which can be further written as log of 12 plus log of 9, and everything is still to the base of 8. Log 12 can be written as what? 4 multiplied by 3. So we have log 4 to the base 8 plus log 3 to the base 8 plus, instead of 9 I can write it as what? Log 3 to the base 8, but I will put a 2 over here because this was in the index. Okay, so next what we can do is log 4 can be written as what? 2 log 2, and 8 can be written as what? 2 raised to 3. So instead of this 3, instead of 3 coming as an index over here, at this step only I will shift it outside. Okay, and this will be written as what? 3 log 3 to the base 8. Okay, now as we know, this becomes completely 1. So here this entire question has now reduced to 2 upon 3 plus 3 log 3 to the base 8. Okay, so now at this point what we should look at? Should we look at A or should we look at B? See, now understand, with A also, nothing wrong with A. But if you look at B, yes, you might have, in fact, actually let me just focus on more on this one. Instead of log 3 to the base 8, I can write it as what? 2 raised to 3, and this index will be now shifted on this side. So this eventually comes out to be 2 upon 3 plus log 3 to the base 2. Now if you look at this, then you should focus more on B, because 16 can be written as what? 4 log 2, and 9 can be written as 3 raised to 2. So out of the indices, I am taking the indices out. So I am basically getting this is equal to B. So log 2 to the base 3 is basically B by 2. And I want what? I want log 3 to the base 2. So that is basically taking reciprocals on both sides. Log of 3 to the base 2 is basically 2 by B. Let's put this value over here. So this comes out to be 2 by 3 plus 2 by B, which eventually comes down to 2 multiplied by B plus 3 upon 3 B. Okay, so I hope you're understanding how, how you can correlate. Log actually is a topic which is nothing but just correlation. That is what is going to be like extremely helpful, and your eye for detail. Once you get that, then you will be able to solve these kind of questions literally within fractions of minutes. Okay, so yeah, now let's try one more. Okay, so here the question we have is log of some value we have in a bracket, and here we have 9. Okay, 3, then we have again log, then again a bracket, and here the base is 2, then we have 1 plus log, then we have a base of 3 and another bracket which says 1 plus 2 log of x to the base 2, and we need to find the value of x. Okay, and this is equal to half. So first thing what we should do is we will take, see, when you have a value over here and we need to simplify, you go from outside to inside. But now we want to find the innermost value. So for that we'll go from inside, so from left to right. That's the better way of saying. Here we did right to left, and left to right is the case when we need to find the value of x. Now when did we do right to left? Let me check if I can recollect. No, this was not the question. This was also not the question. This was the question. No. Yeah, this one. If you see, I had mentioned that if you want to simplify, you go from outside to inside or right to left. Okay. So now at this point, what we will do is try from the left hand side. So first we'll try to remove this log. Now how will we do that? This entire thing will now be equal to what? See, I'm trying to show you how to do this in an exam, okay? So you don't need to write the whole thing, okay? Just put this on your base, and this will be what? 9 raised to half, which comes out to be 3. Okay, so now this entire thing was what? 3 log to the base 2, okay? And everything was ditto. So now if this is becoming equal to 3, the 3 and 3 cancels. So basically this has now become equal to 1, and I want to get rid of this log. So this becomes 2 instead of 1. I will write it as what? 2 raised to 1, and this bracket was what? 1 plus log to the base 3 dot dot dot. So now when you subtract 1 on both sides, I have log 3, and in bracket I have 1 plus 2 log of x to the base 2 equals to, subtracting both sides by 1, so this is becoming 1. So now again get rid of this log, so this becomes 1 plus 2 log of x to the base 2, which comes out to be 3. So this, then subtracting 1 on both sides, I have 2 log x to the base 2 equals to 2. So this is cancelling. So now again get rid of this log. So value of x equals to just 1. This was 1. Oh sorry, value of x becomes what? 2 raised to 1, which is just 2. Okay. So I hope you are understanding. Literally while explaining also, I could do this in under 2 minutes. So this is something which I would want you all to also get a hang of. Okay, so there is no need of writing everything. Just try to do as much calculation as possible on in your mind. Okay, and I know there will be times where you will get scared, or where you will feel that no, maybe I'm not doing the right thing. It happens. As long as the silly mistakes or the some common mistakes are happening before the actual exam, it is absolutely okay. But towards towards the end of it, like by September, October, these kind of questions have to be done within seconds. Okay, you cannot afford to waste 1 minute or more than 1 minute while solving these kind of questions. I'm not trying to scare you all, please understand, I'm not trying to scare you all, but I know how how important it is if you can save a minute over here, and you can use it while solving a tricky question. Okay, so let's try and solve few more. Over here we have, okay, wait, we just do one more. So the question over here is log of 81 to the base, sorry, no, not to the base p, it is to the base 12, okay, is equal to p, and we need to find the value of 3. 4 minus p, sorry, 4 minus p upon 4 plus p. Okay, now here what is the first thing which we can do? I can reduce this 81 in terms of 3, so this becomes p4 log 3. I'll keep 12 as it is because 12 is not a direct square of some number, so let it be that way. Okay, so I can say log 3 to the base 12 equals to p by 4. Now this is where you will realize that if I look at my question, I can also simplify this way. 3, and when I take 4 outside, I will be left with what? 1 minus p by 4. Here also when I take 4 outside, I am left with 1 plus p by 4. So this is cancelling. Eventually we are trying to find the value of 3. 1 minus p by 4 upon 1 plus p by 4. Let's put the values of p by 4 in the question. So we will have 3, 1 minus log of 3 to the base 12 upon 1 plus log of 3 to the base 12. So then this can be now written as 3, 1 minus log 3 upon log 12 upon, sorry, we have 1 plus log 3 upon log 12. Taking LCM, I am now left with 3 log 12 minus log 3, and here we have log 12 plus log 3. Please understand, the log when taken, the LCM of log 12 will cancel. Okay. So next what we can do is, we can write 3 log 12 minus log 3. So that can be written as what? Log 4 plus log 3 minus log 3. And here we had again log 4 plus log 3 plus log 3, right? Because that was log 12 plus log 3. Okay, so this and this gets cancelled. So this comes out to be 3 log 4 upon, here what I can write it as what? I can write it as what? 2 log 2 plus log 3. Okay, so this can be now written as what? Log of 64 upon 2 times log of 6. Log of a plus log of b is nothing but log of a into b. So this can now be written as log of 64 upon log of 36. I can take the integer part as the index, which can then now be written as what? Log of 8 square upon log of 6 square, taking the indices down. So basically I'm left with what? Log of 8 upon log of 6, which can be written as log of 8 to the base 6. Okay, so I hope you're understanding how are we supposed to solve these kind of questions. Okay, now let's try and see if we can solve few more. Okay, so one more question which I think we can solve over here is, yeah, I can use this one. So we have log 10 plus log of x square plus 5x upon log of root 60 equals to 2. Okay, so what we need to find the value of x over here. So what happens in this case is, log 10 we can take it as 1 plus, we'll keep log x square plus 5x as it is, and here we will shift this over here. So log root 60. Okay, so this, instead let's just keep log 10 also as it is. I will tell you why. Because we need to get rid of the logs. Okay, so now this can, when taken on top, it becomes square. So this becomes just log 60, and this can be written as what? Log of 10 multiplied by x square plus 5x, right? So now the logs on both sides can get cancelled, and this also reduces. So we are left with what? X square plus 5x minus 6 equals to 0. So we have x equals to x minus 6 or x plus 1 equals to 0. So here what happens in this case is, we get the value of x equals to 6 or x equals to 1 minus 1. Now just put it back in your question, and if you see, when you put the value of minus 1 over here, the entire log becomes negative. So this value has got to be discarded. Therefore the value of x in this question is supposed to be 6. That is the correct answer for this particular question. Now I will tell you what will be the so in this particular question only, if they had asked us, let's tweak the question, and if they had asked us what is the sum of possible values of x, sum of all possible values of x. Okay, in that case also, if you actually solve this, and you will realize